far ahead, but that's okay. We're in section 5.1. Oh, but we're only doing 5.1, 5.2, 5.3. Okay, so there's going to be a test coming fairly quickly. You guys will get back your chapter 4B test on Monday. There was too much going on this week, guys. Sorry. I was not able to get down 2 playoff games and a doctor's appointment and all this stuff. But anyway, you'll get it back on Monday, and we'll, you guys will do corrections, all that jazz. Probably end of next week. It depends on how much AP practice we do. If we keep doing some FRQs, that might get bumped at the beginning of the next week. But right around here somewhere, or the beginning of next week will be your next test. The slope fields worksheet is due on Monday, but kiddos who were here yesterday, give somewhat of a relief to those kids who were not. What part of the worksheet are you supposed to be doing? The odds. The evens might eventually be due for bonus, but the odds are what I will collect and check on Monday, and then I'll probably get it back to you pretty quick Tuesday or Wednesday, and you guys might be able to do the evens for bonus, like in preparation for the test. But odds are what's due on Monday. There was a bookwork supposedly due today, but remember grace, not grace upon grace, a little bit of grace. God's grace upon grace. Grace upon grace. But this little grace, we're going to check it on Monday. All right, let's go back. We have a lot to do. I have the example up. Any quick questions about logistics or otherwise? Who's that? Ella, go ahead.
How many more chapters do we have?
We have 5.1, 5.2, 5.3, 6.1, 6.2, and we're done.
So that's
Well,
combined test.
we're not done, but we're AP practicing.
Okay, is that like
5.1, 5.2, 5.3 is his own deal, just because it's a separate, kind of a separate idea from 6.1, 6.2. 6.1, 6.2 is very packed, especially 6.2, so it's kind of like 3 or 4 sections. That'll have its own test, and then we're in preparation for the final, which is April 1st. Remember, April 1st is a Saturday, AP exam, simulation, but it's worth your final exams. All right, here we go. Woo! Kiddos, we're trying to match stuff. You do have your notes open because we are going to write just a few more notesy sort of things in order to help us. However, we did basically cover those of you that totally finished book work. Did we basically cover how to complete book work? Brandon, you mentioned you finished it. Yeah. You were able to? Not too bad. Good. So what we're in preparation now for, or what we're working towards, is being able to understand it better and deeper for the worksheet that's due on Monday. Okay. Where does the worksheet start off on? Notes packet is the one that starts with words. Worksheet is the one that starts with problems. Make a slope field. The ones like we did yesterday, right? Question. To make a slope field, do you literally have to have a table with every single point written down? No. What are you trying to look for? Paths to make it quicker. Can you do every single literal point and then make a little baby tangent? Yes. In order to practice that really fast before we go on, can you guys peek at example number 3 real fast? Go back to example number 3 before we go and check your example number 6. I'm going to grab my sweatshirt because it's warm. Ooh, Caroline, can you go up to the front and turn off one of the front lights? Somehow both of them got turned on. There we go. That's a little better. Don't worry, it'll be cold outside. Just wait for the end of class. Okay, so how many points do we have to find slopes for? Oh, this one's nice. Only 9, huh? How do we make a little baby tangent lines? Well, we think about whether or not you actually write it. If you don't write it, just make sure you're spot on and never make a mistake, because if you don't write any work and you get it wrong, they technically will take off all the points. Remember, to find the slopes, let me just do a colon instead. To find the slopes, we look at the differential equation, right? What's the point we need to plug in? 0, 0. This equation is dependent on x's and y's, so maybe we better plug in almost all the points. If we plug in 0, 0, mental mathers, what do we got? -1. -1, how do I visualize? Someone explain it in your own words, especially for those people who got it yesterday. Okay, so from the point? From the point 0, 0, go down 1, go right 1, then what? Yeah. I'm going to do imaginary. I showed yesterday a dotted line, then I say, hey, start connecting in time. Oh, no. Can you go do student speaking? If they need me, I'll come back. Imaginary baby tangent. That's all we're going to write. It's just the imaginary, or not the imaginary, but the
Yes,
BB.
that's not it.
Go ahead and check, yeah, just say.
Miss Deezer, student speaking.
You guys finish the slope field. I might have to go back.
Alright, no worries. You called the wrong room.
Oh, okay, perfect.
This pet's so nice though.
She's very nice. I agree. All right, what else have you guys found? 0, 1, 0, negative 1? Okay. 0, 1, 0, negative 1. What did you get for the slopes of each of those? 0 for both. How do you show 0 slopes? Very, very, very clearly. Make it flat. Horizontal tangent lines, right? Don't they have slopes of 0? Horizontal tangent lines. The slopes or the derivatives are 0. Okay, now what? Would be 1, 0? Negative 1, 0? Those are these points, right? What happens when you plug in those ones? 1 plus 0 minus 1. Negative 1 squared, which is positive 1 plus 0 minus 1. You guys got zeros, right? All of a sudden we got quiet. We scared of mental math. Good thing we're not doing row reducing of matrices like our pre-calculus. I liked it too, but non-mental math is kind of hated it. Our last 2 points, or 4 points I should say, we have 1, 1, we have negative 1, 1, we have negative 1, negative 1, and we have 1, negative 1. We have all the combinations. Did you guys notice if we plug that in, negative 1 squared is 1, positive 1 squared is 1, so all of these in whatever combination of the negatives and positives, won't it just be 2 minus 1 is positive 1? Double check me then, pretty sure. So at each of these points, at each of these 4 points, does anybody double check me, are they all positive 1?
Yeah.
Good. Remember, we imaginarily visualize an up 1 over 1 and we connect in time to make a baby tangent. Connect in time to make a baby tangent. All of them are parallel. Dun, 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 dun. This one's really weird because it's like follow the flow. They're not going to really make you follow the flow unless A, they give you a nice differential equation, like a nice slope field with lots of baby tangents, or it's super clear. This one is obviously not super clear, unless you realize maybe something to the effect of. It's bound to go, let's say it was here, it's bound to go flat-ish. Maybe the diagonal go flat right around there, and then it kind of goes up, and I don't know. But it's not a pretty one no matter what. Maybe that could fit, but either way. They're not going to make you follow the flow if it's so unclear. Let's keep going then. Basically, the rest of class is what if they give you a differential, a slope field, sorry. I keep on saying that backwards. What if they give you a slope field? We did 2 examples yesterday, people that were gone. We figured out example 4 was F and D and example 5 was E, but you might want to look at the video as to the explanation, it'll help. In example 6, they've given us differential equations. They've given us what finds the slopes. They've given us what finds the slopes. Some of these we were able to integrate, and why was that helpful? I could have kept integrating, we didn't integrate this one. What's the integral of sine of x? If we can integrate, why might it be useful? How do you see antiderivatives in a slope field? Follow the flow. Exactly. Antiderivatives follow the flow. Antiderivatives are flowing through all the little baby tangents. Little baby tangents are 2 curves, and the curves follow the flow. So, how did we match number 1 with letter F? The flow is exponential. How do we match number 4, Roman numeral 4, with letter B? The flow is parabolic. If we were to follow the flow. Something parabolic. How do we match number, we didn't match. Where should number 6 go? Did you guys figure it out? Roman numeral 6, dy dx equals sign? D. He's the only trigonometric flow. Does that make sense? He's the only trigonometric flow. And specifically, that's weird. Why does it start at the bottom and go up? Oh, it's negative cosine, so it's flipped upside down. So instead of starting at the top, it starts at the bottom. Follow the flow. The cosine is what the flow is. The sine is what got the tangents. Now, This one was a little bit trickier. How did we match yesterday Roman numeral 3 with letter A? Who can describe in their own words? How did we match number 3 with letter A? Ryan.
Well, when you have only the x, it's going to be the same vertically. But when you have a y, it's going to be all the same slopes horizontally.
Let me go back to that first example we did yesterday. This differential equation was only dependent on x's. I can write on. So for the lines x equals -1, the entire vertical line had the same slope. For the line x equals 0, the entire vertical line, had the same slope. And then for x equals 1, the entire vertical line had the same slope. When you're only dependent on x's, the slopes follow vertical lines. So we saw there was a differential equation that was only dependent on y's, and if it's only dependent on y's, then, can I come up here real quick to letter A? For y equals 0, the entire line of y equals 0 is going to have the same slope. For y equals 1, now I'm approximating, but approximately y equals 1, the entire line follows the same slope. How did I know to make it, and I wasn't actually even approximating, how did I know to make that y equals 2? What's so special about those slopes, guys? They're all flat, aka they're all 0. Oh, wait a minute, what happens to dy dx when y is equal to 0? Sorry, when y is equal to 2. If y equals 2, then dy dx is equal to 0. So sometimes it's helpful to go look at the horizontal tangent lines and be like, oh, hey, when y equals 2, the whole thing has to be 0. That's the only one, the only differential equation that works. Now, you guys are supposed to try to match two other ones. We had c and f that were still unknown, and we had two kind of tricky differential equations that weren't easy to be integrated, number 1. And number 2 had x's and y's. Did anybody make a match they're pretty confident with and can give a description as to why?
Oh yeah, C was 2.
C is 2. Ryan, can you explain the logic as to why that is your?
Well, if you follow the line created by like y equals x, let's just say, it's
Okay.
all going to be, if it's x over y, it's all going to be the same diagonally. So they're all the same, and it's all the same the opposite way.
So he was saying if y equals x, for instance, or for y equals x, dy dx. Y equals x, I could say x over y is x. What should all the slopes be? So do all the slopes seem to be 1 on the y equals x line diagonally? Yeah, it looks like it. Similarly, if you were to say for the line y equals -x, if you were to plug in x over -x, what should all the slopes be? -1. Oh, hey, yeah, those are all pointed down. That's one way to look at it. Another way to look at it is, and this is kind of where my mind usually jumps, so that doesn't mean yours had to right now before I actually talked about these types. This whole line is y equals 0, right? Look at your differential equation. If y equals 0, question, what would the entire differential be? Oh no! X over 0? What kind of slope is that? Why am I writing UND? Undefined. And what kinds of lines have undefined slopes? Vertical ones. Hey look, they're all vertical. Do you see them? Right? They're all vertical lines. The slope is undefined. What else am I going to look at? What if I look at the line x equals 0? If I look at these slopes, maybe you can't see them, but if you follow the flow, they're all horizontal, which means the slope should be 0. Kiddos, what happens if we were to plug into this one? Not dy dx. X equals 0. Dy dx is going to equal 0 over y, which is, hey, it works. Right? Now, do you actually have to show that work? No, I'm trying to show you the mental puzzlings, the mental processing that you might need to go through in order to make it match. But yes, number 2 does go with letter C, which means that by process of elimination, we can say that number 4 goes with letter E, but my question is why? How can we defend that? Let me try to show the graph and the differential equation. Oh, did I just write the wrong thing in roll? I apologize. Bad process of elimination, huh? Okay. Number 5 does go with letter E, but why? Josh, what do you see?
When y equals x, it equals 0.
When y equals x, he's looking at the differential equation saying, hey, something special, cool. When they're the same, it's going to be 0. So when y equals x, we can say that dy dx should be 0. So along the diagonal line, y equals x, this is the only graph that has flat. This is the only graph along a diagonal line that could be y equals x has horizontal slopes. Now guys, it's not always this easy. This is kind of just an introduction. We will get to other clues, but for right now, let's go ahead and just in our notes, composition books, let's talk about this real fast. We're going to come back to that one. Let's do this one next. Do a little different order than our notes. Which of these tricks did we just use at some point in those graphs? Which of the tricks in that matching activity, which of these tricks did we already use? I think so. I think so. We did try to think about where the slopes are 0. Josh just did that. When y equals x, the slopes are 0. We talked about where the slopes are 0. What would make the differential equation 0? We talked about slopes along the x-axis, the special y equals 0, what that does, how that affects dy dx. We talked about slopes along the y-axis when x equals 0, how that affects dy dx. So some of you, the tricks will stick, so maybe you don't have to write all this info down, but some of you are like, oh, I really wish that we could actually like quantify or at least describe, I shouldn't say quantify, but describe what we just did. Here's my attempt to describe what we just did. Some of the different tricks we used. Slopes only dependent on x, aka dy dx, is only in terms of x. Slopes only dependent on y. dy dx is only in terms of y. If it's only in terms of x, the slopes will follow, or parallel slopes. Can I use the parallel symbol? Is that okay instead of writing it? Parallel slopes. Vertically. If dy dx is only in terms of y, there's going to be parallel slopes horizontally. So once again, guys, I'm just trying to describe some of the different things I was trying to model, and some of you figured out on your own that you could use in order to make these matches. The one we didn't use yet, because we didn't need to yet, is number 6. Maybe some of you guys thought about it, if you were plugging in points. Well, maybe we kind of used it. Ryan, you kind of used it in yours. Maybe we kind of used number 6. And the one that Ryan was describing. Number 1, what makes the differential equation 0? Do we see any flat lines in the graph? Or in the slope field? Number 2, when y equals 0, what should the slopes look like? When x equals 0, what should the slopes look like? Is it only in terms of x? Is it only in terms of y? And then number 6, where the slopes are positive or negative? This would be, in a sense, this would be when we are testing points. Meaning, we've done maybe all of the others because they're kind of easier to do first. We've done all of the others and we're like, stink, we still can't make a match because these two are similar in these ways. There's no distinguishing them besides picking a point and testing. Now guys, you can't necessarily in a slope field figure out the difference between a slope of 1, a slope of 2, a slope of 3. You can see it being steeper or less steep. But what you can figure out is it sloped up? Or is it sloped down? You might not be able to figure out the numbers, but you should at least be able to tell, hey, is it sloped up or is it sloped down? Should the differential equation be positive here or negative here? And don't worry, we have some harder matches that we will have to get to number 6 in order to think about. So this isn't something to memorize. It's not a forever card. There's not like a make sure you do step 1 before step 2 before step 3. It just depends on the problem you've been given, but all of these are ways of analyzing a graph. Are we close? Okay, let's see if we can use them, huh? Let's see if we can use them. Number 7. Oh yeah. Does anybody else need to take a picture real fast before I change the slide? But you guys can go ahead and in your notes packet start looking at number 7. The nice thing is you already have the examples, so look ahead. Number 7, we're trying to match it again. We have 4 differential equations. If we have differential equations, are we following the flow or thinking about the slopes? Slopes. Now if we can integrate, can we think about following the flow? Yeah, maybe. What's the only one that we can easily integrate? Because he looks like a normal differential equation we've seen before. Yeah. Which one? Yeah, first one. We can derive, well, integrate that one. Now guys, I'm not going to show the proper move the dx to the other side. It's a matching problem. We're just thinking about it real fast. When you integrate a linear, what are you going to get? We're going to get a quadratic, right? There's going to be stuff to it and plus these, yada yada. That's not our point. It's a quadratic. What's the only one that has a quadratic following the flow? B. You see it? He's the only one that follows the flow. Now, does he have a horizontal shift? Yeah. Well, that's okay. That's not our point. Our point is he's the only parabolic one. He's the only parabolic one. Does that make sense? Cool. Stick-a-dink. Now what? What do you guys think? Alan, you're saying one. What do you think? Is 2C. Why? I like it. Number 2 is only dependent on y. So for the y equals lines, all of the slopes on those horizontal lines should be parallel. Question, kiddos, are all the slopes parallel horizontally? I see that. So since all the slopes are parallel horizontally, only dependent on y, yes, this one is too. Another match. Number 4 is which one? Number 4 is A. How'd you figure it out though? Do you guys see the horizontals? What line is the horizontals, approximately? The slopes are 0, but what line is that? Y equals negative x. The only one, if y was equal to negative x, you'd be able to make it match, would be number 4. If y equals negative x, then yeah, dy dx is equal to 0. So that means number 3 must be D, but why? Maybe. Because some of you don't see that these are horizontal and don't see these are vertical. What, they are? Graphing calculators can't always show vertical lines. But technically, if you follow the flow, right? If you follow the flow, isn't this slope vertical? And if you follow the flow, wouldn't this slope be horizontal? Right? So you might not be able to see the vertical horizontal. Maybe that wasn't the way that you would see letter D. Sadly, anybody who's not watching the video won't benefit from what we just did. But what could you see Question, kiddos. What are all the slopes in the first quadrant? All the slopes are downhill, negative. Which one, if you plug in, wait, what's going on in the first quadrant? Isn't x greater than 0 and y greater than 0? Which one, if x is positive and y is positive, would make a negative number? X is positive, y is positive, nope, that's a positive number. Y is positive, nope, that's a positive number. X is positive, well, sometimes that's going to be a positive number. What's the only one if x and y are positive, will the whole thing be negative? Number. You can check the other quadrants as well. Now, I said in the page before, testing points, we're kind of testing lots of points all at once. But you could have also tested an individual point, like something like, I don't know, 3, 2 or something. You say, hey, what's the slope at 3, 2? Negative, so plug in 3, 2. The only one where you plug in 3, 2 that would be negative would be number 3. Sometimes you have to test multiple points, sometimes you look at quadrants, but those are all ways of doing it. Does that make sense, kiddos? Go look at number 8. While I answer Katrina's question. Yeah, kid. So, like yesterday, we do a couple and then see the following pattern. This one is trickier unless they look at that and say, wait a minute, hold on. X plus negative x, if y is equal to negative x, it's 0. So I'm going to say, hey, if I do 0, 0, negative 1, positive 1, negative 2, positive 2. So we started seeing yesterday, we built a few and then we were able to see it all. So what, like, you have to do it's good to show some. They're not going to show you this many. It's going to be one of those things, only 9 points or 12 points. What do you guys think for number 8? What do you guys think? Let's try number 1 first of all. What do you guys think? True or false for number 1 only? Because if x is less than 0, what quadrants are you in? Yeah, you're in these ones, right? Are the solutions following the flow, are those decreasing? Yes, but what are those doing? Increasing. So is number 1 right? And the answer is no. Number 2, all solutions level off near the x-axis. True, right? AKA, isn't there a horizontal asymptote at the x-axis? Interesting. That's true. I see the leveling off nature. For all y greater than 0, what quadrants are those? Yeah. For all y greater than 0, are the solutions increasing? And the answer is yes. So we can say 1 is a no, 2 is a yes, 3 is a yes, so therefore the final answer is D. Let's keep going. Number 9. Vertical segments. How on earth can they be asking me, wait, what do we know about vertical segments? What slopes will they have? Oh, come on, we just talked about it. Vertical segments. What slopes will they have? Undefined. What does that mean, though? Vertical segments, the slope is undefined. Okay, slope undefined is the clue we get out of vertical segments. But if the slope is undefined, what does that mean about my dy dx? They love to ask this question, kiddos. What does that mean about dy dx? What is an undefined slope? How does it show up numerically? When you plug in, what happens? Number over 0. So how on earth can they be asking me to solve this? They're not. What are they asking you to look at? Just him. What about him? You will have vertical segments when 4x plus 2y equals what? Exactly. We're connecting calc stuff with pre-calc stuff, yeah? 4x plus 2y has to equal 0. Well, I don't know, I can't solve. Well, no, but look at all the answers. All they did was get what? Y by itself. So get y by itself, subtract 4x, divide by 2, y equals negative 2x. Oh my goodness, is that an answer? Dun, 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 dun. Not bad. You have to read the words, connect them with the math, and then be able to solve if necessary. Then be able to solve if necessary. Has anybody already gotten on to example 10? Okay. We have a differential equation. It's one of those, how many is, now careful. This one says true. Could they also ask a question about which are false? Yeah, definitely. Read carefully. If y of 0 is greater than 0, then y of 0, what are they talking about? Isn't that like f of 0? F of 0 is when x is 0, right? Okay, well, what's going on if x is 0? They say if y of 0, which is on the line x equals 0, is greater than 0. Where do you guys see greater than 0 on this line? That's here-ish, right? Okay, so what they're doing is they're giving us a, they're saying look at the slope field and look at all the points where at x is equal to 0, the slopes are positive. Okay, we found the part of the graph where when x is 0, the slopes are positive. What are they asking for number 1? Then the limit as x goes to infinity is approximately 0. What? They're saying pick initial conditions, any of these places, and follow the flow. Alright, kiddos, if we follow the flow here, oh stink, what's the function doing? Is it approaching 0? No, it's approaching infinity. Well, okay, what about these ones? Is that why they told us this? No, it's approaching like negative 2. Okay, does number 1 seem to make sense?
No.
No. Reset. What's number 2 say?
For all x's on 0, for all y's on 0.
So when x is 0, they're saying the y's are in between what?
Negative 2.
So all the negative-y things. Where are all the negative-y ones? Right here? Okay. What are they asking about it? The limit seems to be negative 2. Okay, follow the flow. I see something kind of like, well, these are zeros. Doesn't it have to kind of level out? Oh. Where are all those zeros at? What line is this? Oh, that makes sense. Okay. Yeah. That's true. And then, if y of 0 is less than negative 2, then the limit is 0. If y of 0 is less than negative 2. Does y of 0 seem to be super, super negative anywhere? I see super, super positive. I see super, super positive. I see where it's 0, and then I see where it's negative. Nope, I don't see that one either. Technically, you could say that the slopes do eventually somewhere get to be super, super negative, which would be down here somewhere, because it's getting steeper and steeper. Oh, stink, it says greater than negative 2. Less than negative 2. Kiddos, hold on. Where would the slopes be less than negative 2? Does that mean super steep or not very steep at all? Yeah, and below, aren't they still approaching all of these ones? They're still approaching negative 2? Yeah, that doesn't make sense. Okay, I was right. I second guessed myself for a second. I don't know why. The only answer is B. Okay. Woo! Example number 11. What have we just gotten to?
Here's gone.
A, B, C, and D. That's an FRQ. What?
Sick.
Okay, why is it good that we kind of got here? On your worksheet, guess what's going on towards the end? You make some slope fields, and then you do some multiple choicey ones, and then you have some long answery ones. So guys, we're not going to totally do example 11. Obviously, we only have 3 minutes left. But first of all, how would you do letter A? Now, would you have to plug it in for everybody? No. No. Plug it in for a few, just to show that you kind of know what you're doing, and then if you can find a pattern, go for it. Does that sound good? Okay. Letter B. What does it say? Let f be a function that satisfies the given differential equation. Write an equation for the tangent line to the curve. Oh, wait, they just told me what to do. Write an equation for the tangent line to the curve through the point 1, 1. Then use your tangent line. I'll circle that because I might forget to do that. Okay, so I'm not going to do this, but I'm going to help us think through the hints. Guys, isn't this a forever part? Tangent line, don't I plug in y minus y1? Wait, who's the point they told me? Equals m, isn't that f prime of 1 times x minus 1? And how do I find f prime? I just say, hey, go find dy dx for the point 1, 1. Plug it in, plug it in. Wait a minute, why are they then telling me to use the tangent line? Yeah, remember we can approximate? Plug in, x is equal to, what is it, 1.2? Then we can plug in x is 1.2 and approximate. This is called local linear approximation. There's a section in our notes if you want to go back and review it. Letter C, find the particular solution. Uh-oh, that sounds like solve. With the initial condition. Oh my goodness, that sounds like a... Then use your solution to find. Oh, I better circle all sorts of things or I'm going to forget what I'm doing. Kiddos, if they say find a particular solution, what am I supposed to be doing with my differential equation? Integrating. And how do I integrate? This guy? We use kind of what we were doing the other day where we said, okay, we moved the dx over here. Let's leave the x and the 2. The only guy that needs to come over is the y. The process of separation of variables. We're going to keep on working on separation of variables in section 10.3. Guys, A, B, and C is where the bulk of those points are. I would say 7 or 8 out of the 9 are in A, B, and C. Most of them in part C, Sally. Most of them in part C. Kiddos, work on the odds this weekend. If you can get to the FRQs, if you can get to the FRQs and attempt them, you will have done what I have asked. All right, cool kids, have your book work ready for Monday. Worksheet, get up to the FRQs and start attempting them. See you guys later. Happy Friday. See you at the game tomorrow.